Hello guys, welcome to the video. Today I'm going to show you how to use the HC-SR04 Ultrasonic Sensor. And so in this video I'm going to be showing you all the pins and what they do. And then I'm going to show you how to connect it up to the Arduino. And then I'm going to be showing you the code that it takes to get it working with the Arduino. And then also at the very end of the video, I'm going to tell you something you need to know about the ultrasonic sensor if you want to use it in your project. So without further ado guys, let's get started. Okay, so now we're going to go ahead and look at all the pins that are on the ultrasonic sensor. And so the first pin here is the VCC pin. This pin is the pin that the ultrasonic sensor is going to get its power from. So you just connect positive 5 volts to it and it will work. So that's where you connect its positive power to. Then the trigger pin. This trigger pin is where, like, for example, these two barrels right here, one is responsible to send out a signal, and that signal is going to hit a wall, and then that signal is going to bounce off that wall and come back into the other barrel. And so whenever we want to send out a pulse to go out and hit a wall and come back, we send this trigger pin high, okay? And so we're going to connect this to one of the pins of the Arduino, and whenever the Arduino wants to send out a pulse, we send this pin high and it will send out a pulse. The longer the pulse is that you send to this pin, the longer the pulse is going to be, okay? It doesn't need to be a very long pulse, just a very quick pulse. And we're going to see that example in the code. We're going to see that it's a very small pulse, just enough for the sensor to hear it. And then the echo pin is the pin that is whenever that pin goes out, whenever we send it with the trigger pin, we send that signal out. Whenever it comes back, that signal is going to come back into the echo pin. Okay, it's going to come out the echo pin. Okay, so the Arduino is going to be listening for a signal from the echo pin. And whenever that pin goes high, then we know that signal has successfully hit a wall and can come back. So then we calculate the time, all that. We're going to show you all that in the code. Okay, and the last pin here is G and D. Basically ground, so you just connect that to some ground or something like that and it will work. So yeah, those are all the pins. And so yeah, and so now we'll go ahead and move over to the circuit that we're going to be building this video. So let's go ahead and move over there. Okay, so now here is the circuit that we're going to be building here. And so I'm just going to go ahead and start with the ultrasonic sensor first and how it's connected to the Arduino. So the first pin is VCC or power, and that pin is going to be connected to pin 5V. And then the next pin, which is trigger pin, that's going to be connected to pin 12 right here. The echo pin will be connected to pin 13, and then the G&D will be connected to the ground wire on the breadboard, and then connected to the breadboard will be a wire that's connected to G&D on the Arduino. And so that's how the ultrasonic sensor is connected up. And so now we have all these LEDs right here. And so basically what this project is going to be doing is if the sensor starts getting closer and closer to the wall, these LEDs will slowly start turning off. As we get farther away from the wall, all the LEDs will start turning on. Okay, so let's say we're really close to the wall, only this will be, and this LED will be on. Okay, and if we get so close to the wall, it will be off. All the LEDs will be off. But as we get farther and farther away, it would start from here, and one by one by one, as we continue getting farther away, the LEDs will all start turning on. And so this is the LED the first LED that will start and that will turn on once we start getting farther and farther away from the wall. The LED that's connected to pin 4. Okay, so basically we're going to start over here and come this way. So this LED, I'm going to call it LED 1. The anode is going to be connected to pin 4 on the Arduino, and also its cathode is then going to be connected to a 330 ohm resistor that will be connected to the ground rail on the breadboard. Now you can use any type of resistor that is from 220 ohms up to 470 ohms. You can choose any resistance in between there for an LED, and that'll be perfectly fine. So let's move on to the next one. This one is connected to pin 5. This LED, and the same, it's connected through a 320 ohm resistor to ground. And so that's with that LED. This LED is connected to pin 6, and then this LED over here is connected to pin 7. This one is connected to pin 8. This one's connected to pin 9, and this one's connected to pin 10, and this one is connected to pin 11. They're all in order, so just kind of go from, from the first LED that's going to turn on once you start getting away from the wall. You start at pin 4 and just go all the way up to pin 11. So just connect this all up, connect all the resistors to the cathodes down, then connect it to the grounds, and just connect it like that, and you should be good to go. So that is the circuit. So now I'm going to go ahead and start building the circuit. Alright, so now I'm going to go ahead and connect the circuit that I just showed you. And so I laid out everything, the ultrasonic sensor, the 8 LEDs, and the 8 resistors that are connected to the cathode of the LEDs, which is the ground. I laid that all out so it won't take so long. And so I'm going to go ahead and connect the ultrasonic sensor first. And so the first pin I'm going to be connected is G&D. That pin will be going to the ground rail over here. I'm bringing the wire over here because my breadboard has a break right here, which means these are two different rails. This rail, and this rail are two different rails. The same on this side, this rail and this rail are two different rails. And so I have to connect this to this rail because this is the rail. This is the only rail I'm going to connect ground to. And so now I'm going to go ahead and connect the echo pin, and that's going to be going to pin 13. And so I'm going to go ahead and connect trigger pin, which is going to pin 12. And then I'm going to connect the VCC pin to the ultrasonic sensor, and I'm connecting that to the 5V pin, which is 5 volts. So now the ultrasonic sensor is all done. I think I'm going to go ahead and connect the G&D, which is the ground on the Arduino. I'm going to connect that to the ground rail, to the breadboard. And then I'm going to go ahead and connect all the pins to the LED. Okay, so I'm just going to start on this side, and I'm going to connect my far right LED to pin 4 on the Arduino. Then I'm just going to go on to my left and keep on going. So the second pin I'm going to connect is going to go to pin 5. I'm going to connect to pin 5. And then the third LED is going to be connected to pin 6. And of course, you may not be able to see what I'm doing here. I'm hoping that you'll follow the circuit along that I showed you and connect that up first. But I'm just going ahead and just connecting these LEDs up. This LED will be connected to pin 7. There we go, pin 7. This LED will be connected to pin 8. Okay, so this one is going to pin 9. And this LED is going to pin 10. This LED is going to pin 11, the last LED, to pin 11. There we go. So all the pins, all the LEDs are connected. Hopefully I connected them all up properly. And so now we're going to move over to the code for this project. Okay, so now we're going to go ahead and start looking at the code. So I'm just going to go right into it. So here on the top, we define all of our pins. We have echo pin. Basically, we're going to be storing the number of the pin that the echo pin is connected to on the ultrasonic sensor, which is pin 12. And then we have the variable echo pin, which is going to be storing the number of the pin that is connected to echo pin, which is pin 13. Same thing with all the LEDs, like LED 1, that variable is going to be holding the number of the pin that LED 1 is connected to, which is pin 4, and so on, all the way up to pin 8 is connected to pin 11. So we just store all the numbers of the pins that we're using into these variables. And so then we have constant. This is going to be a constant. That means that we are not going to be changing this variable anywhere in our code. And this is maximum duration. That's what the variable is called right here. And here we have 10,000 right here. So basically this can be changed depending on the area you are working in. Like, for example, I could have an area like this big that I want to sense. Okay, so as my sensor gets closer and closer to the wall, the LEDs need to slowly turn off. And so let's say you have a bigger area, okay? And I made my code to, sense and turn on and off the LEDs based on this distance. But if you have a bigger distance and all of a sudden the LEDs are all going to turn on right in between. So sometimes like you need to adjust this based on how big your area is. Now, how you figure out that number is you can run the code without even changing this, and it will print out how far away the wall is from you. Like, it'll give you this duration. And whatever duration is kind of near, like if it's near like 7,000, like if it's 7,300 or something like that, then you can go ahead and just put 7,000 in. It doesn't have to, you usually need to round down. And so yeah, that's pretty much all you have to do there. And now we'll come down to stage, and this is kind of like, since we have 8 LEDs, we want them to slowly turn off as we get closer to the wall. And so this is going to kind of divide up all the spots on when they need to turn off in this area, okay? As far as you get away from the wall, the stages go all the way up to 8, and then it doesn't go any higher. And so that's basically what the stages variable is. It's just kind of displaying how far away we are from the wall. And so now we're going to go ahead and do int duration. This is just going to be storing the information that our ultrasonic sensor will be getting. It's going to be storing that information in there. Okay, so now we're going to go ahead and go into the void setup, and we're just going to set up everything in here. And so right here, we just set up our serial monitor with the 96 baud rate because we're going to be using the serial monitor to print out the duration. And so then we have pin mode trigger pin, and that's going to be an output. And so because we're sending pulses to the ultrasonic sensor, when it should be put out a ping, we send a high signal to that, so that's an output. Okay, so we're going to set that to an output. And then we do pin mode echo pin, which is pin 13, and we're going to be receiving information from that because whenever that ping comes back, that signal of that ping is going to be coming in through the echo pin, which that means Arduino is going to be receiving that information, so it's going to be an input. And so now we do the same thing with all our LEDs, but they're all outputs. And so then we're going to go to the void loop, which is the main part of our code. We go ahead and just send out a pulse to the ultrasonic sensor, so the ultrasonic sensor can go ahead and send out a pulse out there to measure the reading. And so first, just to make sure we send trigger pin low, and then we delay 2 microseconds. It doesn't have to be long, just 2 microseconds. Just turn load and then go ahead and turn trigger pin on. Okay, so this is our actually pulse, right? When we start turning it on, we're setting the ultrasonic sensor at pulse. And that pulse is going to need only be 10 milliseconds long. And so after 10 milliseconds, that's long enough of a pulse for the ultrasonic sensor to work with. And so now we can go ahead and turn trigger pin low. And so then after that, we're going to wait for this pulse to come back. And so we're going to go down to this line of code, and basically we have the pulse end function right here. And what the pulse end function is going to do, it's going to be looking for a pulse on a specific pin, and it's going to wait there. It's going to be counting the time until that pulse comes, and how long it took for that pulse to happen, it will give us that time. Okay, so we have pulse in, echo pin. Okay, we're saying to the pulse in function, hey, we want you to look at echo pin, which is pin 13. Okay, so we want to look at pin 13. Okay, and we're looking for a high pulse. Okay, so whenever a high pulse comes, however long that took, you want to put that time in the duration variable. So then we'll go ahead and print that out in the serial module. Okay, so now we're going to come down to the next line of code here, and this is going to be making all stages. Okay, so for example, if we have this amount of space we want to work with to gradually turn off our LEDs and gradually turn them on, we need to separate stages on how far away, like this would be stage 1, this would be stage 2, this would be stage 3, and so on. It has to separate stages on when our LEDs are going to turn on based on how far away we are. And so basically the first variable we give it is this in the duration variable, which is the information that we got from the pulse in function. And so what we'll first say, it's going to ask us, okay, what's the minimum value that this duration is going to give us? And that's going to be 0. Okay, and so then maximum duration, that's the variable that we put up here, right here, that we defined it up here. And this is basically the maximum how far away you're going to be from whatever wall you are measuring from. This could be different for you because you could be far away or closer from a wall than I am. And so basically we're giving it to the minimum and the maximum value that this duration is giving us. And so then what we want to go ahead and do is say what the minimum value you want it to convert to, and that's going to be 0. What's the maximum value we want to convert to, and that's 8. We want 8 stages here. And so basically, whenever the maximum duration is at 10,000, that's for me, it's going to be at stage 8. Okay, and whenever the duration is down to 0, then it's going to be at stage 0. And anywhere in between. Like if it's, for me, like if it's 5,000, then it's going to be at 4, because 5,000 is half of 10,000 and 4 is half of 8, so it's going to be on stage 4. Okay, so that's kind of what's going to happen because we have 8 LEDs, so we want 8 stages for each one of those LEDs to turn on or off. Okay, and we're going to put whatever this map function calculates for us into the stage variable. And so then we have an if statement and else statement for every single LED that we are going to be turning on and off. So if we're all the way on stage 8, all the LEDs are going to be on because that's, as far as the way we can be. Okay, so all the LEDs need to be on. If we're only on stage 4, then we need to turn off like half the LEDs. So this is LED 1, and it needs to stay on. If stage is greater or equal to 1, then we want to digitally write LED 1. We want to write to LED 1, which is pin 4, and we want to send that LED high. Okay, that's connected to pin 4. Basically meaning that if this is lower than stage 1, which means probably on stage 0, then we want to come to this else statement and turn it off, because stage 0 means we're really, really close to the wall, and we want to turn the last LED off because we're so close to the wall. And so we don't want to have that LED on in that case. And we do the same thing with this LED. This is LED 2. This is the second LED, and it's going to turn off if the stages variable is not greater than or equal to 2. Okay, so if it's on stage 1, then this LED will be off. Okay, but if this is true, if it's greater or equal to 2, then we're going to come into this statement and do the write LED 2, and we're going to turn it high. Okay, and so if that's not true, then we're going to come to the else statement and turn it off right here. And so then the same thing with LED 3. If the states variable is not greater or equal to 3, then we need to turn it off. So it's like in stage 2, we're not going to want this LED on, we're going to want it off. But if it's greater than stage 3 or equal to stage 3, then we want this LED on, else we're going to turn it off. And so on. We have it all the way up to LED 8, which will turn on stage 8. And that's what we do down here, so on. We do the exact same thing for every single LED, LED 6, LED 5, LED 7, all the LEDs. We do the exact same thing here. I'm just going to kind of show you all the code slowly. We go all the stages right here. We just kind of say if, like LED full. We're going to want to turn LED full on if stages are greater than equal to full. If that's true, then we're going to turn it off. If that's false, we're going to this else statement and we're going to turn it off. Okay, and so yeah, and so basically that's kind of everything. And the last bit of code we have down here is we just delay 200 milliseconds. And so yeah, that is the code. Hopefully you understand it all. You can look over it a couple of times to understand it all. But yeah, that is the code. So now we're going to go and see our project in action. Okay, so now here is the project right here. And as you can see, this is the wall. And so we're trying to measure all the way from over here to right here. Okay, so as you can see, only half of the LEDs are on. And we want them all on at the spot. If we're this far away from the wall, it'll be this far away from the wall right here. We want all these LEDs to be on, okay? But they're not. So what we have to do is we have to do that just in the code. So that's what we're going to go ahead and do now. And so all you have to do is you just have to go to your serial module. Okay, that's the value that it's given us, the duration. So I'm going to move out of the way. And so now the duration is about 5,000. And so what we do is we're going to change this to 5,000. 5,000. And so now it was a bit over 5,000, but that doesn't matter as long as you round down a little bit. That'll be fine. So this should work because you want to get as maximum far away as you want to go, and you just put that duration into here. So now we're just going to go ahead and upload our code, and now this should work. And so now we're going to see the project. And so now here is the project. I'm holding my computer, and so everything may be a little shaky, and the audio is probably bad as well. But so here are all the LEDs. And so now I'm starting moving closer to the wall. As you see, some of the LEDs are going off as I get closer and closer to the wall. You see, I'm very close to the wall now, and all the LEDs are turned off as a backup. All the LEDs turn back on. Oops, you can't see the LEDs, sorry. And then we do it quickly. Do that. So yeah, the project seems to be working pretty well. Okay, so there you go. There's basically everything about the ultrasonic sensor, but now I'm going to go ahead and explain some things that you need to know about the sensor. One important thing you need to know is that you cannot use this thing outside. This thing, there's a lot of space outside, a lot of echo. Usually this works really, really well in a house. Basically, I don't even know if this project even work outside. It probably will a little bit, but not really far distances. And so basically just have to know that. And also something else you need to know about the ultrasonic sensor is that the ultrasonic sensor can only sense up a distance of 400 centimeters. After that, it basically can't sense anymore. It gives you all types of false information. So make sure you stay under that range of 400 centimeters. So I just wanted to tell you that. And so yeah, if you enjoyed this video, consider giving this video a like. Also comment down below if you have any questions. Also consider subscribing if you want to see more videos like this. Thank you all. Have a good day. Bye.